Hello everyone, welcome to the 8085 program practical series. So in today's session we will study about some programs. So the first one is subtract the 16-bit number in memory locations 4002H and 4003H from 16-bit number in memory locations 400H and 4001H. The most significant 8 bits of the two numbers are in memory locations 4001 and 4003, and store the result in memory locations 4004H and 4005H with the most significant in the 4005. So we have to perform 16-bit subtraction and the numbers are in the memory location. I will show that with an example. So this is the particular program. So we do this LDA 4000, then MVIC, and then use this program. I will show this working in the simulator, but first of all let us see what actually we have to perform. So for this particular case we will use this example. So let us assume that we have 10 stored at 4000, 20 at 4001, 05 at 4002 and 40 at 4003, and we'll get the result at this point at these two memory locations. So what exactly the problem says that is we have to subtract this content 4050, okay, from this 2070. We have to subtract 2010 from 4005. So when we do the subtraction, okay, you can see the respective memory locations of 40 is stored at 4003. The most significant bit is at 4003, byte is at 4003. Then this number 02, it is the second one, second number, okay. And then we have 20. So this 020 is stored at memory location 4001. Those are the most significant digits and these are least significant. So when you do the subtraction, let us see what we get. So this is the calculator, okay. So we do this subtraction using hexadecimal. So 4005 minus, so we have minus 2010, so 2010. So we will get the answer 1FF5. So this is the expected answer. This we get 1FF5. Now the result will be such that 1F will be stored here, okay, and 5F will be stored in this location. So this is the result we are expecting. Now let us do the program on the simulator and I will explain step by step. So I have put the code in the simulator. This is the required code and also the data. At 4000 we need 10, at 4001 we have 20, at 42 we have 05, and 4003 we have 40. And we know the expected answer also. I have calculated and showed what we are expecting the answer is. So let us go step by step. Okay. So with the first step, LDA 4000, so the data 10, it gets stored in register A, the lower data. So this has to be subtracted, okay. So what we need is 4002 minus 4000, then next is 4003 minus 4001, and if there is any borrow is generated between these two, it should be passed to the next because it is a 16-bit subtraction. Now next we are initializing register C to check if a borrow is generated or not. So here this carry flag is also acting as a borrow flag. With the next step, what we do is we transfer the contents from A to register B, okay, because we cannot directly transfer the data from memory to register B, but we can do for A. So first data is taken from memory to A and then we transfer it to B. Now in the next step, LDA 002, the data at 4002, that is 05, it gets to register A. So we need to subtract this contents. So 4000 and this subtraction 4000, so 4000 4002. So we need to do this subtraction first. So next is sub B, okay. So next step is sub B. Now what this sub B will do, it will subtract the content of 4002, that is 05 minus 10, okay. So this is what we are getting, F5, and carry is generated. Now next we give the instruction JNC, jump if not carry, to 800E, but because carry is generated, so it won't jump to this 800, but it will actually increment C. So why are we doing this C? As I told you that it is to check if carry is generated, as borrow is generated or not. Okay, so here borrow is generated, so it will increment this C. So C gets incremented, so C becomes 01. So this will be subtracted after in the next when we subtract the higher order digits. Now next is we store the partial result to 4004. So this is the first the lower digit result, that is F5. Now we go on to fetch the next digit Okay, with LDA 4001, the data at 4001 20 it gets stored in register A, and of course we transfer this data to B to fetch the next number. We need to vacate this A. With the next LDA 4003, the data at 3, that is 40, it gets stored in register A. So now we need to subtract this, the data from 3 minus 4001. Okay. So with the next step, it performs the subtraction. Okay, but we also need to subtract the borrow from the previous subtraction. So this next step, sub C, will perform that. So sub C ensure that that is also subtracted. Okay, so the result is 1F, and we need to store the result at 4005, the most significant digit. So this is the most significant digit, and then the halt. So this is the result we were expecting, of course. So the result is 1F5. So as we did with the calculator, and we are getting the same result. So this is how we perform this particular subtraction. Now let us go to the next one. Now in the next part, the next program, we need to find the ones complement of the number at memory location 4400 and store the complemented number at 4300. So this is a very simple program. We first load the content from 4400 to A, and then perform CMA. CMA is complement the content of accumulator. So complementing converts zeros to ones and ones to zero. That is what we have to do. The ones complement is, of course, that we actually make 0 as and 1 and ones and zeros, and then we store the result at 4300. So let us just perform this on the simulator. So this is the required code, LDA 4400. So I have stored the data 55 at 4400. So 55 is 01010101. When we complement, we get 10101010. So this 55 becomes AA. So it will get stored in location 4300. Let us do this. So with the first step, the data from this location 4400, that is here 55, it gets stored in register A. Next we complement. So as you know, complement 55 becomes AA. As I told you, this 55 is 10101. You can see at the below the cursor we are getting the data, and here is AA 10101010. This is complemented. Now next step is to store the data at 4300. So it creates a location 4300 and stores the data at this location. AA is stored here, and this is the halt instruction. So this is how we do this. Now let us go to the next code. Now in the next program, we need to find the 2's complement of the number which is stored at memory location 4200 and store the complemented number at 4300. So here we need to find the 2's complement. So what is 2's complement? We first find the 1's complement, and then we add 1. It becomes 2's complement. Okay. So this is the complete code. So actually, 1 minute. We need, this is the complete code. So this is the complete code. Okay. Now let us execute this on the. So this is the required code. So at 4 through 00, I have stored AA. Of course, I will get the first complement as 55, and then we add 1. So the answer would be 56. Let us see. With the first step, LDA 4200. So data at 420 AA, it gets stored in register A. With the next step, CMA, it gets complemented. So this AA 10101010 becomes 5501010101. Now this is the 1's complement. If we add 1, it becomes 2's complement. So this ADI is add immediate 01. So this instruction adds the adds 01 to the contents of register A. So it becomes 56. Now this is the 2's complement. Okay, and then we need to store it at 4300. So this gets stored at 4300, and then we get the halt instruction. So this is how we execute this particular program. So that's all for this session. Thanks for watching.